I'd like to welcome up our next group. This session is sponsored by Dynetics, our all-day sponsor, as well as Johns Hopkins University Applied Physics Lab and Teledyne Brown Engineering. So this next session is called Developing and Sustaining Lunar Presence, the Proving Grounds for Deep Space Human Presence. I'd like to welcome our panel to come on up now as we get the stage set for you. And I'd like to take this opportunity to once again thank everybody that's making this event possible. First off, my staff, Liana Porta and Marta Sodakova. Thank you very much to both of them for doing tremendous work. Thank you to the AAS board, including our president, Alan DeLuna, for all your help. The planning committee, we really appreciate it. And of course, our sponsors and our collaborators, especially the University of Alabama in Huntsville. So it looks like our panel is just about set. I think so. So with that, I will turn things over to Mark Kirasich, Deputy Associate Administrator for NASA's Artemis Campaign Development. Mark, take it away.
Good morning, and thank you. Welcome to our panel. As you heard, it's about developing and sustaining lunar presence and how this provides the proving grounds for deep space. Today, we're going to give you a little bit of the current status and the progress we're making on Artemis, and then we're going to talk about the future plans for things that we're going to put on the lunar surface to enable science and technology. And then we're going to talk about the science and technology, our plans, what we're doing, and how we're getting there. I'm really excited to be part of this panel today. And our panel includes Erika Alvarez, Dr. Heidi Havlin. Oh, there's Heidi. Accept your sign.
I'm filling in for Renee Weber.
All right, I got it. Ginger Flores and Niki Werkheiser. So thank you very much. Before I hand over to the first panel member, the moderator gets to do a couple of slides. So if I could have the next slide, please. Did we do that? There we go. Thank you. One more. I'm going to give you just a little bit of background on where we are with Artemis. I think you all know that, but just to refresh your memory, if we haven't covered it yet here in this conference, but why are we going to the moon? First off, it's about our country's leadership and strategic presence. And we're taking what we did in Apollo International Space Station and we're growing it even more. Every time people travel to the moon on an Artemis mission, there will be an international contribution as part of that, providing the power and the propulsion to get there in the ESA service module. Gateway is a hugely international collaboration. And the surface systems, we're now getting around with talking to international partners about what we're going to do on the surface and how they'll be around involved. And this really establishes our country's leadership in these international, really complicated international endeavors. Second reason is something near and dear to my heart. I was motivated to do what I did for the past 39 years of my career because of what happened in July 1969 when I watched Neil and Buzz walk on the moon the first time anybody walked on the moon. And I know what we do in Artemis is going to inspire a whole new generation of people interested in science and math and engineering, and it's going to propel that next generation in our economy forward. We know that what we're going to do, we're going to build new technologies, we're going to advance science, we're going to invent new things, and that is going to benefit everybody here on Earth, which in of itself will create opportunities, economic growth. And finally, what we're here about is really getting ready to do our next huge human space exploration effort, and that is to send people onto Mars. So our plans for the next 5 or 6 years, if I could have the next chart, really, especially over the last year, coming even more and more into definition. We're just, these are the first 5 Artemis missions. We are just weeks away from Artemis 1 will be the first time we launch the Space Launch System vehicle with Orion on top and send Orion to the moon on an uncrewed flight test. Approximately 2 years after Orion returns from the first mission, we'll do our first crewed flight test, the first time we'll send people back to the moon in over 50 years on a free return trajectory back to the Earth. And then Artemis 3 in 2025 will be the first time we land humans since the end of the Apollo program. The first time, the first woman and her crewmate will step on the surface. Artemis 4 will see, before Artemis 4 flies, we will launch what is known as the initial capability of the gateway. This will be the gateway's first two elements, a power and propulsion element, and that you can see there with the big solar arrays and the habitable and logistics outpost. That's a habitable module. We'll launch that ahead of the Artemis mission. And then this will be the first time the Block 1B or with the exploration upper stage, which gives a huge benefit to exploration by being able to take more, first of all, giving us more performance and being able to take things like the international habitat with us to orbit and then have Orion carry it to the gateway. This will always be also be a landing mission. It'll be the second time people land on the surface of the moon. And then our fifth Artemis mission, we have more deliveries from Orion and SLS in the form of a spree. It's another contribution of the European Space Agency. It's a refueling module that will give the crew more living volume. We'll also deliver via a logistics module part of the mission of the robotic system that is being provided by Canada. We will, before the crew lands on the moon, we will deliver the first mobility device, which is a crewed unpressurized rover that will allow the crew to traverse farther than they can walk away from the lander and do more exploration. It's called the Lunar Train Vehicle. And then, of course, this will be the third crewed landing. This all sets us up. The next chart, this is only the beginning. The next chart shows us where we're heading, really, to do this sustainable lunar presence, the science. This is what the future looks like. In the center, you can see a big habitat. This is going to allow people to live on the surface of the moon for up to 30 days. We'll be supported by a second rover. It'll be pressurized so the crew can traverse in their shirt sleeves across the surface of the moon. And we'll be doing things that you're going to hear about today, things like in situ resource utilization, things like surface fission power, the things you're going to hear about today. We'll be demonstrating the technology. We'll be using the technology. We're going to need this technology to support these human missions. So with that as background, I'm going to introduce our first panelist today, Erika Alvarez. Erika, welcome. Ms. Alvarez, let's see, what is it you do again? I joke because Erika works for me. Erika is, by the way, I am the manager of the Artemis campaign and S headquarters. Erika is the head of systems engineering and integration for Artemis. And for that, she leads all of the cross-program integration, all of these complex elements we've just talked about that have very complex missions. They have to be integrated. She leads the mission planning for these missions. Erika has been a part of my team for 2 years. By the way, when I started, I had one employee. She was my first person I competed for, and that was about the best decision I think I've made since I've been here. So Erika, welcome. And today you're going to talk about something that we did over the past couple months, down selecting to the regions on the moon that we're going to land this first human mission at. Erika?
Okay, thank you, Mark. Really happy to be here with our systems engineering and integration group. You know, a lot of what we do is set all the early requirements for the implementation for human return to lunar surface. As part of that, we conduct a lot of key trait studies, and we also establish the mission. We do a lot of the mission planning. A lot of that involves all the in-space portions, how we take 6 flight programs, do the cross-program integration, pull all those together to show an end-to-end mission closure. But one of the key parts that'll be the first thing that we do on Artemis 3 is decide where are we going to go. A lot of that is based on a lot of strategic decisions. It's looking at what does the environment look like? What are we planning to expect when we get there? And I'm going to talk to you a little bit about how our team, did a collaborative effort across the agency to decide where we're actually going to target for Artemis 3. So if we can go to the next slide, please. So one of the things about our Artemis missions that are unique is that we actually are going to the lunar South Pole. This is very different from the Apollo missions, which was our last human return to the moon, which was equatorial. When you look at the South Pole, we have data right now coming from Lunar Reconnaissance Orbiter, thanks to our Science Mission Directorate, in which we can go and look at what is the environment that we're planning to expect. A lot of the key things that we want to do is study a permanently shadowed region, which is a region that has never seen sunlight, and it has interesting science and important elements that we want to characterize, collect samples, and return. But the challenge of that is that we really don't have overhead guaranteed sunlight like we did in equatorial. We don't always have direct to earth comm. We can't always see the earth. And if you think of an astronaut working in this environment, it can be very disorienting. There's long shadows, you can have hazards. It's very important to be able to navigate in this region. And it's also important that as we pick a landing site, that we understand what's going to be around the radius and what the topography looks like. So if we can go to the next slide, please. What this video is actually going to show is you can see as we change over time, you actually have a wide changing environment in terms of how you're doing your landing. So you have to have a great approach methodology so that when the lander is coming on approach within that trajectory, it can also be able to use mapping to see where it is relative to lunar surface and make sure that we're not sending the lander to a place that has a slope that we really want to be able to stay away from. So some of those are the constraints as well as our power systems. You know, we typically rely on a lot of solar arrays and solar power. We don't always have guaranteed solar power, and in missions where we're actually going to rendezvous with a lunar terrain vehicle, we have to think of the thermal environment and the power environment that the lunar terrain vehicle will actually be experiencing before it can come rendezvous with the lander. So if we can go to the next slide, please. So one of the key considerations that we did, like all good systems engineers, is we established a list of FOMs or figures of merit that everybody could agree to. And one of those was looking for things like I mentioned, like slope, making sure that we have continuous direct to earth comm. Also looking at places where we have sunlight throughout our 6.5 day expedition. We wanted to make sure that we had good landing accuracy and that we had good resolution of the surface data so we know exactly approximately where we're landing. We also wanted to make sure that we can take all the performance of the Space Launch System and the Orion capsule and be able to orchestrate that with the performance of the lander and be able to do the rendezvous in the cislunar vicinity. And then based on the orbit that we are in the NRHO with the gateway, be able to see that we can always have opportunities to go be able to land and execute and abort from the lunar surface if we have to. Each one of these regions that is shown here on the graph, our team was able to down select to about 13 candidate regions. And then we hope as we get closer to the mission to narrow that window down. What we're doing now is working with science and considering all the key science that we can do within these regions and also looking at strategy to see where we want to start establishing infrastructure so we can start to narrow down the sites. So if we can go to the next slide. This is just one example of the different metrics. And in this case, we have different maps that we're building for each region. In this case, we were looking at slope and making sure that the landing system that we have on our landers can accommodate, you know, a specific number of degrees of slope and that the landing legs could support that. So that's just one of the key ways that we worked with our lander partners to make sure that we were looking at key regions that were giving us the best opportunity of success for good landing. And then if we go to the next slide, I believe now we can talk the science objectives.
Great. Thank you. Thank you, Erika. And our next speaker is Heidi Haviland, and I'm glad I've got that nameplate straight. Good. Dr. Haviland, who many of you I'm sure in Huntsville know, is a planetary scientist in NASA's Heliophysics and Planetary Science branch here at the Marshall Space Flight Center. In her role here, Heidi is the project scientist for payloads and research investigations on the surface of the moon, which is the acronym is known as PRISM, which will be delivered on eclipse flight. Heidi is also the project scientist for the neutron measurements at the lunar surface instrument that will fly on Astrobotics Peregrine mission #1. And finally, she's a science team member on the InSight mission. Today, Dr. Haviland will give us a preview of the science that will be conducted at the moon, how science plays into site selection, and also how science is used in these commercial lunar payload services or CLPS. Welcome, Heidi.
Be with you all today. You could go to the next slide. All right, so the science community has really come together behind the Artemis mission architecture to infuse science into every edge of the program. And they have come together to establish these priorities in terms of science investigations that can be accomplished with the Artemis missions. The number one science objective is to understand planetary processes, to understand and characterize the origin of lunar polar volatiles, to interpret impact history of the Earth-Moon system, to reveal the record of ancient sun and astronomical environment, and to observe the universe and the local space environment from a unique location, to conduct experimental science in the lunar environment, and to investigate and mitigate exploration risks. And so the science community is looking at how do we train astronauts in learning to become geologists, as well as wear all these different science hats. These are really a lot of different science disciplines represented here in these investigations, and that they can be accomplished from the lunar South Pole is really exciting. Next slide, please. All right, and when we talk about landing site considerations, we need to think about having sufficient illumination. And we have a lot of experiments that need to have continuous operations on the lunar surface. And if you're within a permanently shadowed region, that can be a challenge to get power within those locations. We need an availability of a range of sizes for the craters and radial traverses and sampling. This informs our understanding of impact processes. Comprehensive sampling informs our understanding of complex geology of the landing site and its link to surface and internal processes. Accessibility of larger blocks to enable sampling of large crater ejecta is another important objective that we want to study. Proximity and accessibility to PSRs to understand volatile processes, including water, and proximity to multiple geologic units of differing stratigraphic time ages. And lastly, proximity to geologic units that enable specific high priority science investigations such as South Pole Aitken Basin and PSRs. So the ability to do sample return science is really powerful, and we haven't been able to do that since Apollo. And the South Pole is very geologically interesting and important to work together with the engineers to understand these science objectives better. Next slide. And secondly, I wanted to just talk about what we're doing with the CLIPS initiative. This is the working with commercial partners. Commercial Lunar Payload Surfaces initiative was started in 2018. And we currently have 14 vendors that are providing launch and landing services to the lunar surface that NASA is contracting with. And there are currently 8 task orders selected, with another 2 on the way. The first CLIPS initiatives, the task order 2 Astrobotic and task order 2 IM or intuitive machines, will be landing early next year. And this is an important effort on our way to accomplishing the full-scale Artemis mission architecture. These CLIPS landers are small, but they can take, we have something like over 50 science and technology payloads that have been selected. And we're going to be launching to the lunar surface approximately 2 deliveries every year starting next year. These are high-risk, low-cost framework, which really enables a lot of exciting science to happen and helps pave the way for the Artemis economy. Next slide. This is a chart where these 8 deliveries are going. And I won't read them all, but there's a lot of really exciting science that's going to be accomplished here. Next slide.
Yeah, thank you, Heidi. Our third panel member is Ginger Flores. Good morning, Ginger. Ms. Flores is the Director of Human Exploration Development Operations Office at the NASA's Marshall Space Flight Center. In this role, Ginger provides key support to human exploration and transportation projects, including habitation systems, payload and mission operations and integration, and the International Space Station program. And I can tell you from the Artemis campaign that I cannot tell you the incredible support Ginger provides to, for example, to our technical cross-program integration, whether it's communications, navigation, or whether it's to our mission planning, to our science team that's working very closely with the Science Mission Directorate. Mrs. Flores' organization is having a huge impact, pulling us forward. And today, Ms. Flores is going to discuss the habitats and a vision for both here on the lunar surface, as well as how we're going to take people to Mars and where we're going to demonstrate those at the Gateway. Good morning, Ginger.
Good morning. Thank you, Mark, for the introduction and the invitation to serve with you on your last civil servant panel. He promised a photograph of this would be on his mantle, so we'll see about that.
Yeah, thanks, Ginger. It sure will.
And of course, thank you to the AAS-UAH and the sponsors. So a central theme that is woven through all human architectures is the need for safe and reliable habitation. Our habitation systems development team has been leading concept development for future systems for Artemis and for Mars, respectively, a lunar surface habitat and a Mars transit habitat. As part of that effort, they also lead engagement with our industry partners who are critical to these efforts and international partners for potential collaborations and contributions. All right, next slide, please. So you heard some about landing sites and science objectives. So we'll take a moment to discuss habitation capabilities that we need on these longer crewed stays on the surface of the moon or at NRHO at Gateway to truly move to a sustained presence. While we are fully utilizing those systems in the Artemis mission as an analog and a proving ground for Mars. So the lunar habitat or surface hab will initially enable 2 to 4 crew for 30 to 60 days with the potential to evolve beyond those mission durations. Most humans need to breathe and eat and sleep and do all those human things. So this element will provide the crew living space for medical care, for exercise, a kitchen, and crew quarters for sleep and hygiene, and of course, stowage. It will also support EVAs with an airlock and plenty of space for EVA suit maintenance. And then it is also envisioned to serve as the lunar asset that will prove out EVA suit port capabilities, which the community sees as necessary for human exploration of Mars. In addition, a surface hab can serve other critical needs. One of those, due to the elevation of the hab itself, it is an ideal communication hub. Next slide, please. So in parallel, we're developing concepts for the Mars Transit Hab. And this is intended to be the system that when combined with a deep space propulsion element will be the command module that transports that first crew to Mars. Before it does that, though, it will go to the Gateway where it will reside for several years and serve as a platform there that is also a very unique Mars analog and in the lunar environment. This will allow NASA to demonstrate Gateway and Artemis lunar surface stays with increasing durations. And it also simulates the Mars environment of surface ops to and from and orbiting spacecraft after those very long durations. In addition, the transit hab at Gateway will be fully independent and be able to sustain 4 crew with advanced closed loop ECLS, a critical system for Mars transit. And we'll also have that larger volume, which also replicates the needs for that longer duration mission to Mars. Next slide, please. So as you can imagine, there are complex design challenges that we must surmount to accomplish these deep space hab needs. Some of the primary considerations are listed here. Delivery mass being typically at the top of that list. We have to design a habitat that can be delivered to the lunar surface within the launch and landing capabilities that we have, while it's providing a entire suite of critical functions to keep the crew healthy and to support exploration and science research. Of course, we are fully aware of issues around lunar dust management. That's definitely a problem that must be addressed with respect to habitation. And then with respect to outfitting, you may have noticed in the reference concepts or designs that were shown on the previous charts, they consist of inflatable and metallic hybrid concepts. Those will require unique outfitting approaches. But even for fully metallic structures, due to the mass challenges around delivery, we're expected that outfitting will still be required after the system is deployed. So these outfitting and logistics challenges and strategies are at the top of priorities that are being considered and worked by the habitation team and our industry partners. Other challenges are operating after long periods of dormancy, and then the inevitable maintenance and repair that's will be required both of the habitat and surrounding external systems. Next slide, please. So we do plan to take advantage of this intersection of these common space hazards and environments between the moon and Mars, such as you see here listed in the center of this chart: altered gravity, needs around radiation protection and shielding, the harsh environments that we'll see, dust, the distance from the Earth, whether it be a few days or months, a distance with respect to proximity, but also to communication delays, and then just living in confined spaces. So we plan to fully utilize these lunar missions, the Artemis campaign, to ring out these systems that will one day allow us to live and work on Mars. That's it. Mark.
Thank you very much, Ginger. And that brings us to our last panelist, Niki Werkheiser. Ms. Werkheiser is the Director for Technology Maturation in the Space Technology Mission Directorate at NASA headquarters, but also roots it here in Huntsville, right, Niki?
Yes, sir.
Very good. At NASA headquarters, Niki leads the advancement of mid-TRL technologies for future space missions. Niki's technology portfolio includes more than 100 projects within the Game-Changing Development Program and the Lunar Surface Innovation Initiative. These ambitious projects are executed across 8 different NASA centers. I am very well about how Niki's work is spread out with dozens of industry and academic partners. And I will tell you that Niki and I have worked very closely over the past couple of years. It's been really important because we have a small technology development in the Artemis campaign. It's been really important that we look at each other's portfolios to make sure they're complementary, don't overlap, and we do as much synergy as we can to get the most out of our technology dollars. Niki's been a great partner in that over the past years. Today, Niki is going to discuss the technology she has under development and how that technology enables our mission and how she manages it. Welcome, Niki.
Thanks so much, Mark. Appreciate it. Good morning, everyone. I am absolutely thrilled to be here today with our NASA colleagues, as well as with a real live 3D audience. So everybody smile, and I'm so excited to be alive and three-dimensional. And I want to particularly say I'm excited to see some students here. It doesn't feel like that long ago to me, although we don't have to say the number of years, but I was a student here at UAH. And going to the Von Braun Symposium was like Christmas for me, getting to hear speakers. So I am truly honored to be here and hope we get to interact with some of you guys. Okay, let's get started. I'm going to talk about some of the technologies, as Mark said. We really do see our NASA colleagues here in the Science Mission Directorate and in Human Exploration as our customers to develop these technologies, as well as industry. We want to really make sure that we're developing a commercial ecosystem as well. This is our space program, all of us, right? And so we have to collaborate and work closely together. So I'm in the Space Technology Mission Directorate. Our motto there is technology drives exploration. Short and sweet, love it. We kind of align our capability development along, to make it simple, kind of a go, land, live, explore theme. If you look at the top of the chart here, go obviously is our rapid, safe, and efficient space transportation. Then, of course, we have to land, right, on different surface destinations. We want to be able to get to diverse science and human exploration. We're talking about the moon mostly today. We've got Mars and others. And then live is what we're talking about today, right? Sustainable living and working farther from Earth. And so today's talk, I will focus mostly on our Lunar Surface Innovation Initiative, and that you see there in the blue box. And then explore, that's our autonomous systems, robotics. It's so that we can really do these transformative missions and discoveries further from Earth as well. So really cross-cutting capabilities. I will say in space tech, our programs are aligned along the technology readiness levels. So we have our early stage, which has 7 programs in it, works a lot with R&D, primarily universities, also small businesses a lot. And then we have the mid-tier range where I live, affectionately known as as a valley of death, which I like to think of as more of a bridge between the R&D and infusion into the commercial and scalability mission infusion side of things. And then we have our technology demonstration missions, which is our higher TRL, works mostly with industry and does focus on infusion emissions. As a matter of fact, they got a mission going off tomorrow with our lofted payload, so we're very excited about that. I will say that you see there ensuring global leadership in space technology, working with industry and academia is very pivotal for us, creating that commercial ecosystem. And you'll hear that as a theme throughout my discussion today. I think it's really important that we partner. All right, let's go to the next slide. Okay, so what is the Lunar Surface Innovation Initiative? Well, when Artemis came about and we look at all the different technologies we're going to need on the lunar surface, many that you've heard here today from our other panelists, it's really important that we just have kind of this foundational, fundamental infrastructure established on our way to being sustainable. And to be honest, we have a lot of foundational, fundamental questions still. So we want to use the early CLIPS flights that Heidi talked about and are very fundamental to us on the way to the Artemis human missions. So we have 6 capability areas that we kind of broke LSI into. In situ resource utilization, you've heard about a little bit today. I'll talk about it some more. Of course, that's simply using those in situ resources on the moon for production of consumables, oxygen, propellant, things like that. And then, of course, you can do excavation and construction. If you're able to collect those in situ resources, you can then utilize those for construction when you combine them with advanced manufacturing technologies, autonomy, robotics, and assembly for things like landing pads, habitats, storage shelters, radiation shielding, things like that. Now, to do any of this, obviously, we're going to need surface power. You heard a little bit today on some of the solar arrays, and we're developing some of those. But we really need kind of a suite of different capabilities for power. So we're developing things like fission surface power, vertical solar array technologies, power beaming, even chemical heat, but also energy storage, things like our regenerative fuel cells. So we're investing heavily in different ways that we can make sure we have reliable, sustainable power sources. Now, to do anything on the moon, you've heard a lot. I think you've heard the word dust a lot today. We have extreme environments, right? The lunar environment is pretty extreme. The lunar noon can get up to, I think, 150 C. Lunar night can be minus 180. And then those permanently shadowed regions you heard about can get down to minus 240. And we're very interested in those, right? So these are pretty extreme environments. We need to make sure that our rovers, manipulators, all our equipment can operate in these environments. And so that's what we focus on there. And then, of course, mentioning rovers, extreme access. We want to access different locations on the moon. You heard Erika and others talk about landing site selections and how we want to check out different parts. I think it's very exciting. We're going to the South Pole. The far side, we've got a lot of things to focus on in terms of how to get access to things like those permanently shadowed regions. When you think about those, they're really too dangerous for crew members. So we want to make sure that we have systems, robotic systems, autonomous systems that can explore those areas first. And then lastly, but very importantly, dust mitigation. To folks outside of this industry, they might hear dust mitigation and think that sounds trivial at first blush. We learned in Apollo, it is absolutely not. The lunar environment, as well as the regolith, is pretty harsh and volatile, really wreaks havoc on our suits and our other equipment. And you'll notice we don't call it dust solutions, right? You can't really solve it, it's there, but you need to mitigate it. So we are working on active, passive, and operational measures to address the dust. Okay, let's go to the next slide. Oh, and I do want to mention all of these areas obviously individually are important, but we're talking about missions here. And so these are very interdisciplinary. You can see how they all work together and come together to build that infrastructure we need on the surface. All right, let's go to the next slide. So I want to take a minute to talk a little bit about a very important component of LSII, and it was part of the plan from day one. And you're probably going to roll your eyes and go, oh, she's going to talk about another consortium, meetings, we get together, we have fun, we go back to our day jobs, right? That was not the intent of this consortium. From day one, when we put together the LSII, we wanted to make sure that we had kind of a cohesive roadmap, strategy for getting these technologies and capabilities developed across that whole technology readiness pipeline, right? Across all those, not only our programs within space tech, but across our different mission directorates, with industry, with academia, with other government agencies, with international partners, and how are we leveraging the different state of the art that's going on behind firewalls and with different partnering between small businesses and large businesses, et cetera. So we wanted to create a consortium that was a little different than others. Number one, we didn't really see one out there that was focused specifically on technology development and having those discussions about what are our real gaps and how can we close in on those gaps. Secondly, we do have our biannual meetings. As a matter of fact, we have one next week at the University of Texas, El Paso. I hope that we'll see many of you there. There is also a virtual option. You can see the website at the top. But we do have biannual meetings usually in the fall. They're at a member site, usually a university, and then we have a spring meeting. But as importantly, we have kind of consistent, regular dialogue, real kind of rubber meets road dialogue on a regular basis. We have quarterly thematic cross-cutting workshops. These workshops are focused on areas that are usually cross-cutting, interdisciplinary, and ones that have really come up and are driven by the member interest that we work together on. Very importantly, what we wanted to establish that's a little bit different is we have across those different 6 capability areas I mentioned, we also have virtual monthly focus groups. So those technical teams get together and it's the whole swath of the stakeholders from industry, academia, other government agencies, NASA, and we virtually talk about those technology gaps, share where we think the priorities are, and then from that, they've created 35 subgroups, which are led by our members to really dive in and talk about those gaps. Now, who's facilitating all of this is Johns Hopkins Applied Physics Lab. As a university-affiliated research center, they had amazing experience both on the DoD side in developing technologies with Navy and DARPA for many, many years, as well as obviously space missions. They combine that together to act kind of as what we call a system integrator for LSII. So in addition to the consortium and to facilitating that and hearing from the external stakeholders and working those issues, they also work with our NASA subject matter experts in each of those areas to understand what NASA's objectives are, our priorities, our missions and roadmaps, so that they can kind of look across that whole spectrum of what they're hearing back from the external stakeholders and what NASA's doing. And then we have them to write an independent technology assessment each year. And they take all that together. And this is really a way to make sure we're not in an echo chamber and that we're also leveraging all of our partners and stakeholders as well as possible. So they hear from the community. They also do site visits where they go out and meet with different members and kind of see and hear what's going on behind the firewalls, what's really state of the art. Because when we're talking about doing solicitations or partnerships, we really want to make sure we're angling for cutting edge, right? So it's been very successful. We're very happy with LSIC. I encourage y'all to take a look. We do publish all the reports, and there's wiki sites and Confluence sites and monthly newsletters. You can sign up for as little as much as you want. But we do have now over 700 organizations that are working together that's been established since 2019. All right, we go to the next slide. So as we continue to grow, like I mentioned, we've crossed all 50 states, over 700 organizations, and we want to continue growing this and really getting feedback from the community. I'll say, anybody knows me, he's heard me say this before, but one of my favorite quotes I think about a lot when we're doing technology development was from Henry Ford. And he said, if I'd asked people what they wanted, they would have said faster horses. And I love that because it's so true with technology development, right? It's just human nature. You think, how can I take this thing I've got and just improve upon that over and over again? When really in several of the areas that we're working, we're seeing true disruption, right? And we're thinking outside the box. So the more inclusive we are, the more stakeholders we work with, I think we really do get these disruptive ideas and approaches that we're going to need to live and operate further from Earth. So I think that was it for me, and I'll turn it back over to Mark.
Thank you, Niki. Very good. That is it for our panel presentations, and now we're going to open it up for questions. Ginger, I'm glad you're coming back. I didn't know if it was because of the questions you were running out, but Okay. Questions for our panel?
Okay, in the audience, raise your hand first. Who's first? All right, up at the top. Run stairs. No.
Question for Ms. Flores. Didn't see any dates in your presentation. I know it's all contingent on future budgets and the like, but is it possible to project a timeline for procurement and implementation of the habitats that you showed?
Yeah, so we do have planned schedules that are in the overall architecture development in the early 30s with a surface hab arriving sometime in the 30-31 timeframe and transit hab a year or so after that.
Next question.
Got one right here.
Hi, my name is Jacob Goldenberg. I'm a NASA Marshal Engineer. Just question about the Artemis campaign development in general. You have all these various programs, SLS program, EGS, Gateway. I realize ACD is meant to, kind of unify that. How does that evolve going forward? Can you make that even more top down, just, tracking requirements and all that? What is the future of ACD and all that?
Yeah. Hey, Jake, great question. Let me start and then I'm going to ask Erika to expand. But first off, it's a really good question. And you may not know, but our campaign was formed after some of the programs were already established and off and running. So in the beginning, we had to play a little bit of running and catch up. So for example, we did take advantage. ESD had been around integrating the ground systems and SLS and Orion. So we built off them. And then to be quite honest with you, we played catch up with Gateway, played catch up with Lisa Watkins and the landing system. Now, and it's a good thing now, as the surface elements are coming line, we're getting ahead of that. And that's why I'm really glad we have Erika. She's looking ahead and she's coming in with more of what do we want to do with these elements and integrating. I mean, it's hard because she's marrying some capabilities that are designed and built, some that are on contract, and some she has more of an open space. But it's a really good question. Erika, you want to expand on that?
Yeah, just to kind of expand on that, as Mark said, we were heavily invested in Artemis 1 with the existing systems that we had and that we're demonstrating now for our first test flight. So one of the things that we wanted to do was make sure that we understood the bounding capability of those existing systems and how they would play into the overall mission design. What we do in terms of SCNIs, we take all those existing capabilities, we look at the new systems and figure out where do we have gaps where we have to have our new online systems coming in to fill those gaps, and we set the requirements. We do some of that really by doing a lot of MBSE modeling, looking at what elements we have that already have key functions and looking at areas where we have new functions that are needed, like things like communication, things like power sharing, and decide, okay, which of the new elements can actually carry that. Another big part of what we do is not just on the requirements development side, but we start to look at our ConOps and start to set our design reference missions as the overall bounding capability of what are we going to go ask these systems to do. So it's the what are we building, and then what are we asking them to actually go execute and do. We use those DRMs to kind of also help set the boundaries of where we need to draw our requirements. And then we also work with all the programs that we look at all the places where they have intersections and they have interfaces. And we're building lots of interface requirements documents across the two that we know will be part of the overall certification effort. So some of these are just some of the classic methods that we use in order to integrate all the systems. And then we always have key functions that we knew we weren't able to fit, but we know are enabling. And so that helps us set the pre-formulation of the new elements that we know we're going to be bringing into the picture that we didn't have with the 6 existing flight programs now. And we have an architecture group that we work with to help give that feedback to them to say, hey, it would be really good if we had this type of new system. And then they can work with international partners or they can work within NASA to decide, okay, how do we want to go and get those other existing functions and bring them back into the architecture? So that's kind of just broad brush how our group does it.
And I'll add just one more thing to give an example too, how great these groups have been. That we have areas like dust mitigation that we've heard a lot about today that, I mean, it's ubiquitous, right? It's everywhere and everything. That's one of the key gap areas. So we work closely together. I think there's over 50 gaps right now across dust mitigation that affect all these different systems. So we also established a position called technical integration managers, because even with our subject matter experts, you have thermal and avionics and ISRU, it affects everything, right? So these technical integration managers work across the mission directorates, across the programs, and in these different forums to help phase and prioritize all those different gaps as well, so we can tie the budget and the schedule to them.
Thanks, Erica. Nikki,
Right.
Jake, great question.
Right over here, stay, audience left.
Thank you. Mehdi Lally, Systems Engineer at NASA IVMV. I have two questions, if that's okay. My first question is for Ms. Alvarez. Is your site selection process driven by the existence of water for institute research utilization as well? Does that include that criteria?
Yeah, so one of the things that we're doing right now in the site selection process is we're taking baby steps, and I would say this is the first time we execute the process for Artemis 3. We also have a team, I'll be remiss to mention, across the Artemis campaign. It's called our Mission Definition and Utilization Team, and they're setting the key mission objectives and prioritizing the objectives for 3. So what we do is we map those objectives. So for example, if we want to do something like in situ resource utilization or do a demonstration of that, that would be part of, okay, how do we rank that across all the objectives and help map that to where we pick the sites. The other things we're looking into is making sure that on the early missions, we're not spoiling future sites. So we have to anticipate when we think we're going to have those demonstrations, those science applications, and those instruments to be able to facilitate things like those objectives, and making sure that we understand the phasing of that so we don't inadvertently spoil something on an earlier mission. Does that make sense?
Yes,
And
it
I
does.
wanted
Thank
to
you.
mention too that there's several CLIPS missions that are going to measure and characterize water content at the poles, including Viper.
Okay, my second question is for Ms. Werkheiser. For surface power supply, are you considering nuclear energy as well?
Yes, so fission surface power is one of the things that we are pursuing. As a matter of fact, I think we just made some awards in the area. We're working very closely with DOE and DARPA in those areas. So that's one of our major goals, absolutely. Yeah, as well as things like the vertical solar arrays that we talked about.
Good. Thanks, Erica. Heidi and Nikki.
Hello, I'm Peter Summers, a student at the University of Alabama in Huntsville. As shown on one of your earlier slides, NASA's partnering with SpaceX for the HLS system. They're using Lunar Starship, which is projected to have a capability of over 100 tons to the lunar surface. In terms of ground systems, habitation, power, and science, how is NASA preparing to take advantage of such an incredible capability to the lunar surface?
Yeah, great question, Peter. I'll take a cut at this. And for one of my first parts, I'm going to tell you there's a couple of subsequent panels that are going to go into more detail on the subject. But I will tell you right now, we've acquired the landing service that has a huge capability, and we are discussing how. And for example, even on Artemis 3, we had a plan to deliver a small amount of science, and because of the Starship's capability, we've asked for more capacity aboard that first landing, and we're gonna increase the amount of science that we bring to the surface of the moon because of the Starship capabilities. So that's what we're going to be doing step by step. It really, the Starship's a bit of a game changer. It opens up a lot of different possibilities: delivery of future elements, delivery of heavy, massive cargo elements, flight elements to the surface of the moon. So we're looking at all these things, discussing how might we use the Starship capabilities. By the way, I would mention right now, we only have Starship under contract for one landing. It's the Option A first landing, and we're working with SpaceX now on the second landing, which is a contract known as Option B.
Yeah, just wondering, the international partners have expressed a great deal of interest in being down on the lunar surface as part of their role in the program. Are they being involved in the mission design? And also, are you getting an impression, or is their interest principally tied to lunar science, or are they also interested in the work we need to do at the moon in order to be ready to go on to Mars?
Anybody want me to start? Or do you want to go ahead, Erica?
Yeah, I would say they're actually interested in both. What we've been talking with the international partners is that they can supply anything from an instrument to a science package to something that we can actually do data sharing to something larger, maybe like Ginger mentioned, we have a lot of logistics challenges. We have challenges of getting all the mass that we really need to do a mission closure and getting that to the lunar surface. So we are talking to international partners that are looking at other delivery systems in order to be able to go there. I also would be remiss if I didn't mention that their pressurized rover that was seen, I think in Ginger's package that has a mobility habitation function is also an international partnership with JAXA. And so we are also working with the partners to also build, large elements on lunar surface that can actually enable expanding our footprint, doing longer traverses, like what Niki mentioned, is trying to actually push the not just uncrewed but crewed capability of being able to kind of travel further. Mark, anything you wanted to add to that?
I think you hit it, Erica. The answer is yes, they absolutely are involved in our mission planning. We have an architecture group and they're plugged in there and they're exploring all different ways to participate on the surface. Science, flight systems, as well as of course, they're interested in their people from the country walking on the surface with us.
And one other thing to add is we have several payloads that are flying on CLIPS deliveries from international partners.
Niki, you had anything else to add? And technology, yep. You see across the spectrum.
I think we have time for maybe two more quick questions. We have one here.
My question is for Ms. Flores. Ginger, I'm Reggie Spivey from Tulane Brown Engineering. Just wondered, with the HAB modules, do you foresee any payload facilities in those modules, something like maybe a glove box?
Yeah, research utilization is definitely one of the high priority use cases. Those are being traded as, we envision this first singular element, but, eventually there's architecture trades with possibility of multiple modules, some more focused, some flexible. Yes, I envision a suite of facilities. Glove boxes are always highly used. That would definitely be a priority for science for utilization.
Last one.
All right. My name is Lisa Moore and I'm a grad student here at UAH. But before that, I was in commercial nuclear energy background. And we only had to death-proof things against the kindler, gentler environment of Earth. And listening to this, I'm wondering, are there any collaborations underway to take some of the best practices developed under this to improve terrestrial and commercial grid resiliency, or possibly test some of these in our commercial grid where it's closer to home to troubleshoot if something goes wrong?
Niki, you want to start?
Yeah, I can say most certainly. Of course, there's the Clean Energy and Climate Change initiative, and we are definitely mapped into that. We've actually taken several of our technologies across power, but also in situ resource utilization, for example, that do have applications there. So we are absolutely working that. Yep.
I think that's it.
Any closing remarks? Any
Yeah, we
closing
might have
thoughts?
missed a key slide. Can we go back one? Let me make sure. I'm not sure which way this is. I think I went off script. It's always the danger with me. Oh, no, two. Let's go forward one. Yeah, closing slide. I hope you recognize, we had people that build flight systems as represented by Ginger, people who really architect things, do the cross-program integrations. But then we also had the utilization community represented by science here today. We also work very closely with the Human Research Program. And finally, Niki represented the Technology Directorate. And it's really important, I can tell you from running that campaign, it's been really important as we assemble this, that from the day one, we're looking across all of these disciplines, that we're pulling in science, that we're pulling in technology, that we're pulling in users, because the goal of this is to make this sustainable, to make this long-term. So we are doing Artemis together, and together means everyone. So thank you very much for your time. Enjoyed it.